Welcome to True Projects. In this video, we are going to explain about a project titled Machine Learning Algorithms Comparison. The advancement of machine learning had a significant impact on healthcare, particularly in heart disease detection and prediction. With the abundance of medical data, machine learning algorithms have demonstrated their potential in accurately identifying the patterns and risk factors related to the heart disease. This research delves into the utilization of machine learning for predicting the heart disease, emphasizing the potential for enhanced diagnostic precision, early intervention, and tailored treatment approach. By harnessing the sophisticated algorithms, machine learning opens avenue for improving the cardiovascular healthcare and ultimately making a difference in saving life. The main objective of this project is to evaluate and compare the effectiveness of various machine learning algorithms such as Naive-Bayes, KNN, logistic regression, local outlier factor, DB-scan, autoencoder, and the isolation forest for predicting the heart disease. By using the heart disease dataset, the objective is to identify the algorithm that achieves the highest accuracy and to gain the insight into the performance of each algorithm in accurately detecting and classifying the cases of heart disease. These are the requirements that are needed to build this project. The hardware requirements are operating system as Windows, processor of i5 and above, RAM of 4 GB and above, hard disk of 20 GB and above. Software requirement Python IDE with version of 3.7. These are the modules that are developed to build this project. The first module is upload the heart disease dataset. This module involves uploading the heart disease dataset to the application for further processing and analysis. The second module is pre-process the dataset. The dataset is pre-processed in this module, which include handling the missing values, normalizing the features, and potentially performing the feature selection or engineering to prepare the data for training the machine learning models. And the third module is run logistic regression. This module focuses on training and running the logistic regression algorithm on the pre-processed dataset. The algorithm learns pattern from the input features to predict the presence or absence of the heart disease. And the fourth module is run Naive-Bayes algorithm. This module trains and runs the Naive-Bayes algorithm on the dataset. This probabilistic classifier that assumes the independence between the features and calculate the likelihood of an instance belonging to the specific class. And the fifth module is run KNN algorithm. This module implements the k-nearest neighbor algorithm, which classifies the new instance based on the majority class of the k-nearest neighbor in the feature space. And the sixth module is run DB-scan algorithm. The DB-scan algorithm is used in this module to identify the dense region in the feature space to form the cluster and effectively separating the outliers from the main group. And the seventh module is run isolation forest algorithm. This module utilizes the isolation algorithm, which can utilize outlier detection method. It isolates the anomalies by constructing the random decision trees and identifying the instances that are easier to isolate. And the eighth module is run autoencoder algorithm. This algorithm is employed in this module to learn and reconstruct the input data, capturing the essential features in a lower dimensional representation. The reconstructed data can be compared to the original data to identify the anomalies. And the ninth module is accuracy comparison graph. This module calculates and plots the accuracy of different algorithms. The comparison graph provide the insight into the performance of each algorithm in predicting the heart disease. The execution of the project. To execute the project, first we need to open the code folder. This is the code folder consisting of different files. The first folder is dataset folder consisting of dataset and the dataset information. And this is the main code file, and this is the run.bat file. Instead of executing the program in the command line interface, we created the Windows bat file to execute the project. Now to run the project, double click on run.bat file. This is the graphical user interface. With this, we are interacting with the program. Now click on upload hard disease dataset. By this, we are uploading the dataset by importing the dataset folder and then click on open button. Here we can get a screen of dataset is loaded and consisting of 303 rows and 14 columns within it, and then click on pre-processed dataset button. Here the dataset is pre-processed and consisting of 303 total records. Here the dataset is splitted into the training and testing part, where the total number of records used for training the algorithm is of 242 and total number of records used for testing the algorithm is of 61, and then click on run logistic regression button. By this, the logistic regression model is generated on the pre-processed dataset and giving an accuracy of 85.2%, and then click on Run Naive-Bayes algorithm button. By this, the Naive-Bayes algorithm model is generated on the pre-processed dataset giving an accuracy of 85.2%, and then click on Run KNN algorithm button. By this, the KNN model is generated and giving an accuracy of 59%, and then click on Run Local Outlier Factor Algorithm button. By this, the factor local algorithm is generated with the pre-processed dataset and giving an accuracy of 49%, and then click on Run dbScan algorithm button. Here, the dbScan algorithm button gives an accuracy of 83.47%, and here in this graph we can see some records are set in 0 cluster and some records goes to the cluster 1, and then close this graph and click on Run Isolation Forest algorithm button. By this, the isolation forest model is generated on the pre-processed dataset and giving an accuracy of 39.3%, and then click on Run Autoencoder algorithm button. By this, the autoencoder model is generated by using the pre-processed dataset and giving an accuracy of 36%, and then click on Accuracy Comparison Graph button. By this, we get a bar graph where x-axis represents of the algorithms we used and the y-axis represents the value of each algorithm and its accuracy, and then close this graph. In this way, we can compare the machine learning algorithms by using the hard disease dataset. Finally, in conclusion, machine learning algorithms have proven to be effective in heart disease prediction, offering the improved diagnostic accuracy and potential for personalized treatment strategies. The evolution of various algorithms such as Naive-Bayes, KNN, logistic regression, local outlier factor, dbScan, autoencoder, and isolation forest on the heart disease dataset provides the valuable insight into their performance. Leveraging the machine learning in cardiovascular healthcare holds great promise for enhancing the patient care and reducing the burden of heart disease.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.